Hello students, so the first question which we will try to understand is classification of memories. So the question will be explain classification of memory. This question can be asked for 4 marks. So I will give you the basic idea. You make sure that you are making a note. This will be your assignment for this chapter. For every topic I am teaching you, you have to make a note from the book. Of course, everything is available in the book. So The memories are classified as primary memory and secondary memory. So basic classification of memory is primary memory and secondary memory. Now under the heading primary memory, see, when you have to explain things, for example, primary memories are the memories where the data which is currently being used is stored. Please listen to it carefully. Primary memory is a memory where the data which is currently being used is stored. And in secondary memory, the data which is not currently being used but can be retrieved back later is stored in secondary memory. So I'll take a simple example. Suppose you are using a laptop and you are writing something on the Microsoft Word. So what happens is, when you are writing a word, or you are writing something on the Microsoft Word, it is actually you are storing the information in the computer. But what happens is, unless and until you save, suppose if you are not saved the document and current goes off or you switch off the computer, what happens? The data will vanish. That means when you are writing whenever writing your letter or application on a Microsoft Word, what happens is the data is being stored temporarily. Of course, you can see on the monitor whatever you are writing, whatever you are typing on the keyboard, you can see on the monitor. That means the data is getting stored in the data is getting stored in the computer, but it is in the temporary fashion until you save the data. So until you save the data will be in primary memory. The data which is currently being used is stored in primary memory. Of course, it may not be in a permanent nature. It is in temporary nature. But once you have completed the writing letter or application and you have saved the data, now what happens? Once you save the data, it goes into the secondary memory. It is a bulk data memory. So it goes into save. So next time, even if you switch off the power and n number of times you want to retrieve, you can retrieve the data from the computer. So that is a permanent memory. So this is the basic difference. So when you are writing or when you are immediately giving some information to the computer, it goes into primary memory, and then the bulk data will be transferred into secondary memory. So primary memory is further classified as RAM and ROM. RAM stands for random access memory. ROM stands for read only memory. So when you classify this type of memory, this is called as volatile memory. And this is called as non-volatile memory. That means volatile memory is temporary memory. Non-volatile means it is a permanent memory. That means if when the data is stored in the RAM, it is in the form of temporary. Nature is temporary. So once the power is switched off, the data will be vanished. But ROM, non-volatile memory, the data will remain as it is even if the power is switched off. Now I'll give you an example of what kind of data is being stored in ROM. Now when you boot up the computer or the laptop, what happens is you see a Microsoft window, right? A window of Window Explorer or whatever operating system you have, that Windows 10, that screen, blue color screen will appear on the computer. Before that, something goes on from the bottom of the computer to the top as something written on white in a black background. That means some data is being processed before the operating system opens up and you see your desktop. That data is called as, of course, that data is called as basic input output system program. That means every time the laptop is started or the computer is started, it will check all the peripherals connected to it. It will check all the internal peripherals which are connected to the computer or the laptop. So for that, there is a program called as basic input output system program, that is called as BIOS program, basic input output system program. And every time you switch off the computer and switch on, the booting process will initiate. That means the BIOS program has to run. That means that data has to be permanent. So that data is stored in ROM, that is read only memory. As the name indicates, only data can be read from the memory. Data cannot be stored, or you cannot transfer data to that memory. You can only retrieve data from that memory. So whenever a BIOS program has to run, the BIOS program is there in the ROM. From there it goes to RAM, and from there the program will be executed. So whatever you see before the Windows Explorer screen is nothing but the BIOS programming. It is checking its internal peripherals. Now of course, as I said, that will be first stored in RAM, and RAM will execute the data. Now once that is done, and suppose the Windows Explorer Windows Explorer desktop is open, now what you are doing is, suppose a Word file is, you are opening a Word file and you start typing something. Now what happens is, now the data has to be temporarily stored, and that data when it is temporarily stored, it will go into RAM. Of course, already RAM has a data, BIOS data, so it has been made in such a way that the old data will keep on moving out of the RAM and new data will keep on entering into the RAM. That is why it is called as temporary. So now when you are writing the letter, the BIOS program which was stored in RAM will keep on moving out, and the data which you are giving, the information which you are giving to the laptop or the computer, it is getting stored into the RAM. But if the power is switched off, the data will be vanished. Therefore it is called as volatile memory. Now further, RAM is classified into two types called as static RAM and dynamic RAM. Static RAM and dynamic RAM. Now static RAMs are designed using flip-flops. We have already studied flip-flops, and we can store the data as 0 and 1, and unless or until we change the data will remain as it is. So the static RAMs are designed using flip-flops. Dynamic RAMs are designed using capacitors. Capacitors are basically used to store charge. A fully charged capacitor is considering to be stored as digital 1, and a completely discharged capacitor is considered to be stored the data as 0. So that is how a capacitor can be used as a data. But what happens is, the capacitor has a tendency to leak charge with respect to time. As I said, a fully charged capacitor is considered to be storing data as 1. But if the capacitor tends to leak charge with respect to time, what will happen? At some point, all the charge of the capacitor will be removed, and the data which was there as 1 will now change to 0. So data can corrupt in a capacitive memory. So what has to be done is, for a capacitor you have to keep on refreshing the data. refreshing is required. You have to keep on refresh the data. Refresh the data means whatever charge which has been leaked out of the capacitor, that charge has to be stored back, so that the data which is there, the data 1 which is stored in that capacitor, that data will remain as it is. Whereas in case of flip-flops, refreshing not required. Now what happens is, cost wise this is very high, flip-flop memory, whereas capacitive memory, it is very cheap or it is very low cost wise. So cost wise this is very high, this is very low. And again volume wise, if you can understand, say volume, if you can understand, to make one memory so I need one flip-flop. To use one flip-flop I need two gates, at least two gates, and to design one flip-flop I need two gates, and at least to design one gate I need 4 transistors. That means I will be required 8 transistors, 1 2 3 4 5 6 7 8. So 8 transistor will make one memory location, whereas in capacitive memory, one capacitor has one memory location. So in a single chip of say 1 by 1, what happens is, if you can see, the volume of the number of memory location using capacitor will be much higher as compared. This 8 dots makes one memory, here 1 dot will make one memory. So on a 1 by 1 chip, the number of memory location in dynamic RAM will be more as compared to static RAM. So volume wise capacitor memory is more as compared to static RAM. Sometimes there will be a question of differentiate between static RAM and dynamic RAM. So you have to specify these points. Static RAMs are designed using flip-flops, dynamic RAMs are designed using capacitors. Static RAM, no refreshing is required. Capacitive, refreshing is required. Static RAM cost is very high, dynamic RAM cost is very low, and volume wise static RAM is less as compared to capacitive memory. Whereas if I say capacitive, so capacitive memory has more volume as compared to static RAM. So these are the difference between static RAM and dynamic RAM. Now ROM, read only memory. As I said, the data only can be read, but data cannot be stored in the memory in case of ROM. But so when the ROM or the BIOS program has to be stored, manufacturer used to store BIOS program in the ROM, and then the laptop or the computer used to come to us. But then after some decade, there was a necessity that as a user I should program my computer. So there was one more modification which has been done, called as PROM. PROM stands for programmable read-only memory. That means as a user I can program that, but once it is programmed, only once it will become ROM. That means you cannot store the information once again in the memory. It has to be read only. So then there was an advantage, there was a requirement of a memory, a ROM, where we can program it again and again and again. So that was EPROM, erasable programmable read only memory, where you can erase the data number of time and program. But to erase the data, the chip has to be exposed to ultraviolet rays. That means all the data will vanish as soon as you expose it to ultraviolet rays. So data will be vanished, new data has to be substituted. So you can reprogram that memory, erasable programmable read only memory. But then all the data will vanish at the same time. So the next advancement which was done is EEPROM, electrically erasable programmable read only memory. Here you can go into one memory bit and you can change the data from 1 to 0 and 0 to 1. So repair is also possible, and of course the entire data can be erased and new data can be substituted. So that was the advancement which has been done in case of ROM. Next is secondary memory. So secondary memory, of course, a bulk data, a memory location where bulk data can be stored. Of course, you know CD and pen drives. These are all memories where bulk data can be stored. They can all be example of secondary memory, but I will go and I will try to explain you things which are specified directly on your book, so that you can write the same thing in your copy. The first thing which was done is the first memory location is called as magnetic tapes. So I don't know, you were all born in the era of CDs and iPods, so I don't know whether you have seen or not a magnetic tape, a tape recorder. A cassette will be there, you put it into the tape recorder and you can listen to songs. And if you have seen the cassette, it will have a brown color reel, and on that a brown color coating will be a magnetic coating, and the magnetic alignment will decide the data as 1 and 0. So that is magnetic tape. But you can, if you have seen or if you have heard a cassette, if you are hearing the first song and you want to hear a fourth song, what you have to do is there is a forward or reverse button in the tape recorder, and you have to go sequentially 1 2 3 4, then you have to go for fourth one. That means you have to forward the data so that you can go directly to the fourth. Sequentially you have to access the data, so the retrieving rate of the data will be very, very small, and a limited amount of information can be stored in magnetic tapes. Then there was an advancement on that, and that was called as floppy disk. I don't know whether you have seen that disk or not. A black color, a square jacket will be there. In that a floppy disk. Floppy means very thin. So a thin plastic will be there, and above that there will be a magnetic coating which will be done, and on the magnetic coating a magnetized area is considered as 1 and a demagnetized area is considered as 0, and that is how 1 and 0, the data will be stored in the form of 1 and 0. And whenever you put the disk in the disk drive, a head will be in constant touch with the film and it will retrieve the data from the floppy. But as the floppy, as the layer is very thin, the rotation rate was around 300 rpm, rotation per minute, and it's a very slow speed, so data storing and data retrieving will be very slow. Now what happens is, as the speed was slow, the head was in constant touch with the film, and the life of that film will be very less, so it will use to get corrupt every usage of say 4 to 5 times. So then there was an advancement, and that advancement called as, that was hard disk. So it was a rigid disk, and when the disk is rigid it can be rotated very fast. So the speed of hard disk was 3000 rpm. So now when the speed of the disk is so fast, what happens is there is a air cushion between the head and the film or the disk. So the head is not in constant touch with, still it is retrieving and storing information in the hard disk. The lifespan of that hard disk improves. So in all respect it will be much better as compared to floppy disk. And both floppy disk and hard disk, the data can be retrieved randomly. Here it was sequentially, here it is randomly. So the data retrieval rate will be very fast as compared to magnetic tapes. So this is the basic classification of memories. So what you have to do is, you have to explain each and everything: primary memory, secondary memory, what is RAM, what is ROM, then what is static RAM, what is dynamic RAM, then classification of what is PROM, EPROM, EEPROM, and then you have to write at least 2-3 lines about hard disk, floppy disk and magnetic tapes. All of this you will get in your book, in your textbook, Phadke Prakashan, chapter number 7, paper 2. So just write 2-3 lines of about all this, and you will get an explanation of this classification of memory. So draw this diagram and write that explanation. That will fetch you 4 marks for this question. the second question which we will try to understand is block diagram of a personal computer. So whenever such type of questions is asked, what the image we have, what is a personal computer, what we can see is monitor, keyboard, mouse, CPU, right? This is what we try to imagine, but this is not what we have to draw. We have to draw exact the schematic diagram of your personal computer. I will explain that. Now, what is the basic use of your personal computer? No, it's not to store data. Most of them understand things in that way. That means the computer is basically used to store information. No, it is used to process the information at a very high speed. Basically, whenever you are writing a data, you are watching a movie or playing a game, actually what happens is the computer is processing digital or binary information at a very high speed. It is performing arithmetic and logical operations on that data so that everything appears properly on the screen. So basically, personal computer is used to process the data, binary data, at a very high speed, and the basic block which does that is called as ALU, called as arithmetic and logical unit. Now, as I said, the arithmetic and logical unit will perform complex arithmetic and logical operation on the data. But where the data will come from? Of course, the data will come from a block called as primary memory. All the data which is currently being used is stored in primary memory. So I draw a bidirectional arrow. The bidirectional arrow indicates that the data will go from ALU to primary memory as well as from primary memory to ALU. Suppose if the data is not available in the primary memory, then the data has to be retrieved. Data has to be retrieved from secondary memory. Secondary memory. So if data is not available in the primary memory, the data will be retrieved from secondary memory. If the data is not available in primary memory or secondary memory, of course there is an option with the data can be given to the computer through keyboard. Suppose if you are writing a letter, it will be keyboard. Suppose you are transferring a bulk information, that is scanner. You are scanning a book and storing the information in the computer scanner. And then suppose you are playing a game, the input can be given through a jack, a joystick, right? You used to play a game. So all these are called as input device. So the input device will be there. Input device which will provide data to the primary memory, and from primary memory then it will go to arithmetic logic unit. Here now you can see the arrow mark will be on only one direction. That means data can be only transferred from input to memory, primary memory, and data cannot be transferred back from primary memory to input device. So that is unidirectional. And then once the data is processed, the data will be sent to the output device through primary memory. All this data you watch on an output device, which can be a monitor. If you are listening the song, it will be a speaker, right? Or if you want to print that data, it will be a printer. So we say this is output device. So data will be then transferred to output device, and then the most important of all this block is called as control unit. Is called as control unit. See, what happens is the computer performs data at a particular speed. Every computer has its own speed. It is mentioned in the CPU 2 gigahertz, 1.2 gigahertz, 1.3 gigahertz. Like this, different speed will be there. So there is a internal trigger pulse, which we call it as clock pulse, which indicates all the peripheral, what function it has to perform and when it has to perform. So that means the control unit controls the speed as well as the performance of all the blocks. So there should be a signal which has to be transferred, from control unit to all the peripherals. It tells all the peripheral what function it has to perform and when it has to perform. So this is the basic block diagram of a personal computer. That means ALU will perform all the logical arithmetic and logical operation, complex arithmetic and logical operation. Data will be provided by the primary memory. If the data is not available, data will be provided by the secondary memory. And then if the data is not available in both the memory, it will be provided by the input device. The data will be processed by the ALU. It will transfer the data from primary memory to secondary memory, or from primary memory to the output device directly. And to control all the peripherals, to tell all the peripherals what function it has to perform and when it has to perform, a control signal will generate control signals. So this is block diagram of personal computer. I hope you have understood. The next question which has been asked in board exam several times is list any 3 input device and explain any one of them. So of course in the previous video I have told you what are the input device which will transferring data into the computer. Data will be transferred into the computer, right? Through the primary memory it will be transferred to ALU. So basically the input device will be keyboard, then scanner and mouse. All these are example of input device. So you have to list any 3 input device and explain any one of them. So these are the 3 input device. Out of that you will explain keyboard. Of course it is there in your book. You have to just look at the notes, the book, and you can see the information. Now there are 3 types of keys to the keyboard. They are called as alphabets, numeric and special keys. Sorry, not alphabets and numeric, they will come under the same heading, and special keys and function keys. So of course from you can easily understand, you have seen the keyboard, that alphanumeric is they are the keys from A to B and 0 to 9. All these keys come under that heading, alphabets and numeric. Function keys, on the top of the keyboard you can see F1 to F12. All these function keys, just pressing one key or one function key, you can perform a number of tasks simultaneously. Therefore it is called as a particular function key. And special keys, as you can have shift, delete, enter, etc. All these are special keys which will perform a special task to perform all the operations. So this will be the question: list any 3 input device, explain any one of them. You will list the 3 input device and explain keyboard, and you get the note from the book. The next question is list any 3 output device and explain any one of them. So you have to list 3 output device like the previous question. The 3 output device now, of course, it is monitor, printer, speaker. These are the 3 output device. Out of this you will explain printer. It is readily available in the book, all the information, just have to go through it. Printers are of 2 types: impact printer, impact and non-impact printer. Non-impact printer. I hope everybody must have seen a typewriter. So whenever you press a key on a typewriter keyboard, when you press A, what happens is a key from A will go and hit the ribbon, and after the ribbon there will be a paper. So ribbon will go and hit the paper, and there will be an alphabet A which will be printed on the paper. So this is called as impact type. So there is an example called as dot matrix. Dot matrix, this is an example of impact printer, and non-impact printer will have two examples. It is inkjet printer and laser printer. So in a dot matrix, what happens is, a dot matrix has a matrix of tiny needles in a nozzle like this. So suppose A has to be printed, so A shaped dotted lines will come out and will hit the ribbon, and of course the paper will print A. So a letter will be printed one at a time. It will complete the statement or to the entire line, and it will again come back to its initial position, start writing from the second line. So this is called as line by line printing, and it is impact printer, as it will be in constant touch with the paper. Inkjet, now inkjet has a tiny nozzle and it will spray ink on the paper. There will be no direct contact between the paper and the head. It will spray ink on the paper, and that is how it will form an image. So suppose a dot will be created, and or the dot will be combined together to form a letter A. So it will be again one by one, it will print the letter, the entire line will be completed, it will come back to its initial position, again second line will be printed. This is also an example of line by line printing, but again it is a non-impact printer. And the last one, which you already know, is laser printer. So in laser printer there is an internal drum which will be there. The entire page will be copied on the drum, and when the page moves through the drum, and when it comes out, the entire page will be printed at the same time. So laser printer, the quality is very good as compared to dot matrix and inkjet, as well as the speed of printing is much faster as compared to both of them. So you get all this information in the book under the heading printer. So just go through this and make note of this, at least this topic. Thank you. The last topic of this chapter is concept of bus. Now bus is nothing but a group of wires used to transfer binary information. I will take an example so that you can understand. The microprocessor, or the computer, or the heart of the computer, microprocessor, communicates with input-output device and memory. Of course, the data will be stored in memory. Whenever the data is required by the computer, data will be transferred from memory to microprocessor, or sometimes once the data is processed by the microprocessor, data from microprocessor has to be stored into the memory. So now what happens is, so data will be communication will be done between microprocessor and memory. Now whenever the data has to be stored or retrieved from the memory, the microprocessor needs address of that memory location. That means the data will be stored, there are number of memory location. So data will be there in the one of the memory locations. So microprocessor has to know the memory address of that memory location. So for that there will be a group of wire. There will be a group of wire which will be connected between a microprocessor and memory, and this group of wires used to transfer address of memory location, location. So every time the data is to be retrieved or stored or transferred back from memory to microprocessor, what has to be done is microprocessor will first send address of the memory location. The memory has a memory management unit, MMU. The MMU reads this address, it will go to that address and it will retrieve the data which is stored in the memory. And then there is another group of wires which will transfer that information, from memory to microprocessor or from microprocessor to memory, called as data bus. This is called as address bus. So there are three types of bus: address bus, data bus and control bus. So what is an address bus? What you can see is address bus, what you see, the arrow mark is only in one direction. That means address will be always provided by the microprocessor to the memory management unit. So it is unidirectional. Whereas data bus, arrow in both the direction. So both the direction means data can be transferred from microprocessor to memory or from memory to microprocessor. So it is bidirectional. So we say a group of wires used to transfer address from microprocessor to memory is called as address bus. That is A. B, a group of wires which is used to transfer data from microprocessor to memory and memory to microprocessor, it is called as data bus. And of course all this information will be transferred under the control of control unit. So control unit will generate a signal for all the peripherals to tell what function it has to perform and when it has to perform. So the group of wires used to transfer this control signals is called as control bus. So a group of wires used to transfer address from microprocessor to memory management unit is called as address bus. A group of wires used to transfer binary information from microprocessor to memory or from memory to microprocessor is called as data bus. And a group of wires used to transfer control signals from control unit to all the peripherals is called as control bus. So this is one more question which has been asked several times in your board exam. So I have explained you 5 questions. Sixth one is differentiate between static RAM and dynamic RAM. So the first question is classification of memory. Second is differentiate between static RAM and dynamic RAM. Third is block diagram of personal computer. Fourth is list any 3 input device, explain any one of them. Fifth is list any 3 output device, explain any one of them. And sixth is concept of bus. So you have to just prepare this 6 question. Out of this question, out of this 6 questions, there will be one question which will be 1 or 2 questions which will be asked for 3 marks or 4 marks. So make sure that you prepare. And for this chapter, only for this chapter, I want you to make notes from the book. Of course, I am providing you notes of all the other chapters. Just for this chapter, you have to make sure that you are preparing your notes by your own. That will be a practice, a kind of practice for this chapter. So it is not very important, but you have to go through this chapter properly. Thank you so much. Hello students. Having understood the block diagram or the memory classification, in that there was a very important point which I had discussed under the heading RAM. If you remember, the basic classification was primary memory, secondary memory. Under the heading primary memory, there was further division of RAM and ROM. RAM, as I specified, they are volatile in nature. Volatile means as soon as power is switched off, the data will be vanished. Okay, and ROM is a permanent memory. So the basic BIOS basic input output system program, that is the program which is used to boot the computer, will be always stored in ROM, because every time you switch off the computer and switch on, the computer has to boot, and that program is stored in a permanent memory called as ROM. So what is there in RAM? See, the first important thing is, whenever
the program stored in ROM, that is basic input output system program, is run, it is run through RAM. That means data from ROM will be put it into RAM and then it will be run. And after doing that, once the program is run, you will see the window. Suppose you are using a Word file and you are storing the information. Now this is the data. As a user, I am storing it into the RAM, which is a volatile in nature. So what happens is the data which was already there in RAM will keep on moving out of the RAM. It will keep on vanishing, and as a user, the new data which I am going to store will keep on entering into the RAM. That is how it works. And if in between, suppose as I said, Word file, if you have opened a Word file and you're typing something, and in between power is gone. So what happens is, if you have not saved the document, all the data for that particular document will get vanished, because RAM is a volatile memory. That means the data will remain in RAM till the power is there. As the power is gone, the data will be vanish. Okay, so the basic user programs are stored in RAM first, and once the Word file is finished, what you will do is you will save the Word file, where you will save C:, D:, E:. What is C:, D:, E:? It is nothing but the auxiliary memory, that is the secondary memory, which is nothing but the hard disk, right? We took an example of hard disk, floppy disk, magnetic tapes, but what we are going to do is we are going to store the information in hard disk or external memory or pen drive or CD. These are all auxiliary memory, right? So initially the data goes into RAM, and once you save the data, it goes into the secondary memory so that it can be retrieved back later. Okay, now we are extending it into one more topic. I've mentioned in that tree diagram that the RAM are further classified as static RAM and dynamic RAM. Okay, so now in this topic today, in this video, we will try to differentiate between static RAM and dynamic RAM. In that video also I have explained you what is the difference. Here we will clearly mention it as difference, because this question has been asked in your exam. Okay, so static RAM and dynamic RAM. As the name indicates, static means which doesn't change, dynamic means which is continuously changing. Okay, so the first point which we are going to write in static RAMs, so static RAMs are designed using flip-flops. We have already studied that, designed using flip-flops. They are designed using flip-flops. Okay, so that will be the first point. So when you design a memory using a flip-flop, the output will remain 0 or 1 unless and until you give a trigger, and unless and until the power is switched off. Once the power is switched off, the data will vanish, even from the flip-flop also. So as I said, flip RAM is a volatile memory. So even static RAM and dynamic RAM, both are volatile memory, but there is a difference in that. What that difference is, that is what we will try to understand here. So the first point, as I said, in static RAM, it will be designed using flip-flops. So until the power is there, the data will be there, and unless and until you trigger, the output will not change. The memory element, it will be working as a memory element to store 0 and 1 in the form of 0 and 1. Next, second, dynamic RAMs are designed using capacitors. We have studied capacitors. You know this component. Basically, capacitor is used to store charge. Okay, so there will be two probability of the capacitor. Is the capacitor completely charged? Or maybe the capacitor may be completely discharged. So if you consider it in the digital form, there are only two values, 0 and 1. So if the capacitor is completely charged, we consider the capacitor to be storing a data as 1, and a completely discharged capacitor is considered to be storing and digital information or a binary information as 0. I hope you have understood. One capacitor acts as one memory element. Completely charged capacitor is considered to be storing 1. Completely discharged capacitor is considered to be storing 0. Okay, so this is the first difference. So this is designed using flip-flops, this is designed using capacitor. Okay, second is the most important point. Okay, second point is the most important point. Here refreshment is not required. Refreshment is not required. Okay, refreshment is not required means, as I said, till the power is there, data will be there. Once the power is gone, data will vanish. So when the power is there, you don't need to manipulate the data. The data will remain as it is. Okay, there will be no changes unless and until you provide the trigger. But what happens is dynamic RAM is, as I said, capacitors, basic use of capacitor is to store charge. Completely charged capacitor is considered as 1, completely discharged capacitor is considered to be 0. Now the capacitor has a tendency to discharge or lose charge with respect to time. So now see, it's a very important condition. Now suppose you have stored data as 1, that means the capacitor is completely charged. And what is the property of capacitor? To lose charge with respect to time. So after some time, if the charge is charge leaked out of the capacitor, what left? No charge, and no charge means that particular capacitor is considered as 0. So the one which you have stored now has become 0 after some time. Is that, of course, it should not happen, right? That means the data will get corrupt. So that should not happen. So what it does in dynamic RAM, every few milliseconds we see the capacitor which is containing 1, that means which is charged, and whatever amount of charge it has leaked through the capacitor, that charge will be redeposited in that capacitor. Okay, so that is what is called as refreshing the capacitor. That means even when the power is on, the capacitor has a tendency to discharge. So even when the power is on, at some point the data will vanish, but that should not happen. Therefore refreshing is required. Refreshing is required every few millisecond. Refreshing is required every few millisecond. Okay, so this is the second point under the heading dynamic RAM, which is very important point. Okay, so the third point is volume. I will explain you what exactly I mean by volume. Okay, suppose static RAM, there is a 1 inch by 1 inch chip in both the cases, dynamic RAM as well as static RAM, 1 inch by 1 inch. Now here one capacitor acts as one memory location. So if you have 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4, this chip has 16 memory locations, right? So how many bit can be stored? One capacitor stores 1 bit, 16 capacitor will store 16 bit. So this is the memory volume of memories within a single chip. Okay. Now in case of static RAM, as I said, static RAMs are designed using flip-flops, and if you remember, we have studied SR flip-flop and SR flip-flop using NAND gate, SR flip-flop using NOR gate. So just to design one flip-flop you need 2 gates. Okay, whether you are using NAND gate or NOR gate, you need 2 gates. So for one flip-flop you need 2 gates, and for one gate, if you remember logic families, to design one NAND gate, how many transistors we used? We used 4 transistor and 1 diode. So 2 gates required, 8 transistor and 2 diodes. Okay, so designing one flip-flop requires 8 transistor, 1 2 3 4, 1 2 3 4 and 2 diodes. So it has occupied this much space, and this much space will give you one memory location. So how much this memory location? 1 2 3 4 5 6 and probably 7 8 9. Here 16 memory locations, and here the volume was 16. One capacitor amounts for one memory location. Here 8 transistors and 2 diodes amounts for one memory location. So you can see how much of circuit will be needed in that 1 inch by 1 inch chip. So of course the volume of memory location is less as compared to dynamic RAM. Volume of memory location is less as compared to dynamic RAM, whereas volume of memory is more as compared to static RAM. So this is a very important point. Volume wise, dynamic RAM are more. That means within a small chip of 1 inch by 1 inch, more memory location will be occupied as compared to static RAM. So dynamic RAM has more volume as compared to static RAM. And fourth one is the cost. Okay, fourth one is the cost. Of course, as I said, to design one flip-flop, you need how many? One flip-flop, 8 transistor, 2 diodes. Okay, so as you keep on increasing the memory location, the number of transistors and number of diodes will keep on increasing, which will increase the cost. Whereas in case of dynamic RAM, one memory location is one capacitor. So the charge or the cost of the designing of dynamic RAM is much cheaper as compared to static RAM. Okay, so cost is more compared to dynamic RAM. Dynamic RAM cost is less as compared to static RAM. Okay, so these are the 4 important points if there is a question on differentiating static RAM and dynamic RAM. Okay, DDR, they are called as DDR and SDR. Okay, so static RAM and dynamic RAM. I hope you have understood.